Triangle Day, Part 3. The only thing I changed to get to section 6.1F is to add a water to your halogen. And it's a bigger story than that. This combination is called bromine water. So what's happened is you've added bromine to water. Water's the solvent, water's a reactant. Water is both. Solvent and reactant. And that combination has been mixed and then stored for years or whatever. It's on the shelf, ready to go. What they don't tell you is on the shelf, it's reacted already. The bromine reacted with the water. And I don't think this will be a huge shock. The water comes and attacks a bromine and the other bromine leaves. So this is a new step that you didn't have with the other reactions. And you get a Br minus, which is just kind of, if somebody asks me what I just drew, I'll be happy. I wanted to make it so small that you could barely see it, because it's not really relevant anymore. It's just going to float around in solution and not do anything all day. It's kind of a new kind of spectator. It's a Br minus. Now, I get students who say, that's an oxonium. That's a strong acid. I know what to do with strong acids and alkenes. And they attack the hydrogen. They forgot the whole exercise where I'm asking which reaction is a lot faster, the one where you attack a hydrogen in the strong acid or attack a halogen that has a lone pair that can prevent an octet violation. Sorry. That's the one I like. Which one's faster? Attacking the strong acid or attacking the halogen? Which one's faster? Halogen. Don't attack the strong acid, please. Do not attack the strong acid. Attack the halogen that has the lone pair. That's why I put the lone pair there. So you attack the halogen, water gets kicked off, and the lone pair comes back to which carbon? The more substituted carbon. I'm just going to keep asking that question all day. There's going to be another instance of which carbon? In this mechanism. Same answer. Time to make a triangle. Here is your triangle. Carbons in black. Methyl here. Bromine on a dash in green. Double dash. Don't forget, it's got a charge. What's the charge? What's the charge? The other product is water. And it doesn't matter that the other product is water. There's more water than anything here. How do you know that? There is more water than anything here. It's the solvent. So I don't have to use that water. I can use any of the waters that was there from the beginning, but I happen to draw it and it's there, so I'm going to use it. The backside attack on which carbon? More substituted carbon. That puts the O on the more substituted carbon, and O is more electronegative than Br. So who's the Russian guy? Markovnikov. He says this is a Markovnikov result. Of course, he didn't say it at all. It was after he was around that expression was invented. And what's the backside of a dash? A wedge. So you better draw the new one on a wedge. And please note that it still has two H's because you haven't touched the H's yet. And the Br, that bond survived. The other one did not. Somebody's going to tell me the relationship between this and the final major product. There's a relationship between the pair. I use the word pair for a reason. Yeah, that's an ion, but that's not the relationship between this particular pair. It's a very exact relationship. Two species different by only one proton. Conjugate acid-base pair. Which one's the acid? Top or bottom? More H, bottom. Yeah. Now the question is, what's the best base to grab the H? And some of you want to use that Br minus that I made right in the first step. Water's a better base. I'm going to prove it. And there's a lot more of it. Don't have to prove that. Solvent says it all, right? So water is going to react. Yes, this is your second time you've used water. And that is the end of that mechanism, part A. Vicinal, new word, very good word, on adjacent atoms. Now it's based on the word that we use in English, vicinity. If things are in the vicinity, that means they're close to each other, right? This is a little more exact. How close? Adjacent carbons. What are the two things on the adjacent carbons? Vicinal, halohydrin. Answer to C is hydrin. What's a halo? I don't think I have to answer that question, but I am going to. Halogen or halide, however you want to call it. Halo, how about a halo group? Chloro, bromo, iodo, they end with O. Hydrin must be the other new thing. You already know the name of the other new thing. It's one of our 8 functional groups. Yeah, it's not 8. It's 14 functional groups. You knew 3 alcohols, 3 amines, 3 amides. What started as 8 group? Yeah. Hydrin is just alcohol. It's old school for alcohol. Old chemists still call them hydrins. When you get into biochemistry, you're going to use a stain called ninhydrin for staining proteins. Guess what functional group ninhydrin has? An alcohol. Yes. Okay, and one last thing here. Why is water the strongest, the best base to use? It's not really part of the quiz, the activity. The new question, water, the best base, not Br minus 1 and 2. It is the solvent. There is a large excess, always for solvent, right? pKb of water, wow. pKb for H2O, 14 minus, what's the pKa of hydronium? Ladies and gentlemen, pKa for an acid plus pKb for its conjugate base is 14. Fact. So what is water the conjugate base of? Hydronium. Remember, the base has 1 less proton, the acid has 1 more. So water, add a proton, you got hydronium, -3. It's a bad base, but compared to Br minus, it's not as bad. 14 minus what number? HBr. Wow. 19. Lower number, stronger base. higher number, higher number. I'm not gonna write weaker, I'm not gonna write anything apparently. There you go. That's an activity with extra. Stop sharing.